So we're continuing topic 2.5 and 2.6, and we're going to look at finding the derivatives of polynomials now. So these are the sum and difference rules. So basically you can do the sum or the difference of two functions is differentiable if the sum and the difference of their derivatives. So if I see two functions being added together, kind of like having x squared and x, I just take the derivative of each one individually and I continue to add them up. Then we can do the same thing if it's a minus sign. So we're going to find the derivative of each of the following. Some of these probably need to be simplified before I find the derivative. So in A here, I would probably rewrite this as f of x equals x cubed over x minus 4x over x plus 5 over x. And I'm going to go ahead and simplify it. Notice I haven't done any derivatives or calculus yet. I'm still doing algebra. So when we have a division sign here, it means we have to subtract the exponents. So we have 3 minus 1, which would be x squared. And then these x's would cancel, so I just have minus 4. In order to take this derivative, I need to bring this exponent upstairs, so I'd have plus 5x to the negative 1. Now I'm in the sum and difference rule, and I can take the derivative. Now that it's all on the same level, there's no denominator anymore. So f prime of x, remember that notation means that I'm now taking the derivative. I bring the number in front, the exponent in front, and I subtract 1 off of it, so I get 2x to the first. We know the derivative of any number is 0. I'm going to take this and bring it to the front, so we've got minus 5x. I'm going to subtract 1 to the negative 2 power. To clean that up just a little bit, f prime of x equals 2x minus 5, and then bring this back downstairs is going to be x to the second. All right, in B, before I try to do B, I can't just have this being multiplied together. We need another rule, which we're not ready for yet, but we have a rule already in algebra that would help us. We could FOIL that. So I'm going to do algebra first. So I've got x squared times x would be x cubed. And then my outsides would be x squared times, that is a minus 3. So x squared times negative 3 would be negative 3x squared. And then 1 times x would be 1x. And then 1 times negative 3 would be negative 3. There's nothing for me to even combine together, so I'm just going to go ahead and take that derivative. So this cubed is going to come out front. The exponent comes out front, and I subtract 1. So I get 2. This exponent here comes out front, so we've got negative 6x, and I subtract 1. And then I take the derivative of this. Basically, again, the exponent comes out front, so it'd be 1 times 1, which is 1, and then I subtract 1, which gives me x to the 0 power, which is just 1. And then the derivative of any number we know is 0. So I'm going to write one line cleaning that up. I normally would have just not written the x and the 0, but I'm making sure we're showing all the steps today. So 3x squared minus 6x plus 1. All right, so there are a couple of basic algebra rules that are really important in calculus, and we've already kind of seen this a little bit earlier in the lesson. We do need to be able to convert radicals back into exponents. So remember that the root part always goes at the bottom, so b over a would be what that looks like. And then this one here, and we used it a few times, is if I have a number, so any number like a 3, okay, in the top over x to a variable, I need to bring I frequently will bring this up to the top. So it will be whatever the number is, x to the negative a. Okay, looking at C. C is definitely ugly. I am going to have to FOIL and then some. So I've got x minus 3 times x minus 3 times x minus 3, right? Cubed means I'm writing it 3 times. So I'm going to do some algebra for a bunch of lines. So x times x, I'm FOILing the first two together. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x, and negative 3 times negative 3 would be positive 9. I'm still multiplying that by this last x minus 3. I'm going to simplify the middle. So I'm combining like terms. I'm adding these guys up. I get negative 6x. Now, I can't FOIL anymore, so I am going to get out the box. I'm going to put it kind of towards the bottom. This is just to help keep my work organized. If you like the rainbow method, you can use the rainbow method. So we've got x squared minus 6x plus 9 over, and then x minus 3. So x times x squared is x cubed. X times negative 6x is negative 6x squared. X times 9 is 9x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 6 is positive 18x. And negative 3 times 9 is negative 27. So as I'm writing this up there, I'm going to combine like terms. You'll notice your diagonals are usually your like terms. So we have x cubed, and then negative 3x squared and negative 6x squared is negative 9x squared. 18x and 9x would be 27x minus 27. Now I am finally ready to take my derivative. So I'm taking the derivative of this. I get, bring the exponent in front, so 3x subtract 1 squared. Bring the exponent in front, so negative 9 times 2 is negative 18x. And then 27 times, or we're going to bring the exponent in front. 27 times 1 is 27. Would be subtract 1, which would make it x to the 0. The derivative of that number is 0. So if I was just going to write it pretty and clean, it would be 3x squared minus 18x plus 27. All right, we're going to use a couple of these properties, algebra properties, in D first. So we've got that g of x equals 2x squared minus 3x. I'm going to split this into two separate fractions, which I'm allowed to do. And I'm going to convert that denominator to x to the 1/2 power. You have to be seamless in the fact that you understand that the square root is the 1/2 power. We use it daily. I need to make my exponents so that I can subtract them. So they need common denominators of 2. So 2 is the same as saying 4 over 2, and x is the same as saying 2 over 2. So now I'm going to subtract my exponents. We have 2x to the 3/2 minus 3x to the 1/2. All right, now we're going to take our derivative. So again, I bring this in front. I'm going to show that work this time. So we've got 2 times 3/2 x. We're going to subtract 1, which in this case would be a 2 over 2. So 3/2 minus 2/2 is 1/2. Minus 3, I'm going to take this guy, bring it in front. So I'm going to multiply by 1/2. And then we're going to subtract 2 over 2, which is 1. So I get to the negative 1/2 power. All right, the 2's are gone. So we get 3 square root of, or sorry, I'm converting way too fast. 3x to the 1/2 power. And then this one here, nothing cancels, so I just get negative 3/2. And then this would be x to the negative 1/2. It's possible they leave the answer like that, but you got to be prepared for lots of different things to happen multiple choice. I could convert this guy back into a radical, so it could say 3 square root of x. This one is going to probably pop downstairs, so it could say 3 over 2x to the 1/2, and then that does not look like an exponent, does it? And then they could take this and convert it back into a radical, so they could say 3 square root of x minus 3 over 2 square root of x.